So I have here cloned the source code of the Linux kernel, and we're going to make a slight modification into the keyboard driver to make it type weirdly. Now the way I'm going to test this is using QEMU, and QEMU actually simulates the old style of keyboards. If you remember the PS2 keyboards, they look something like this. You had one port for the mouse and one port for the keyboard. And this is basically what the QEMU emulator emulates, and also a lot of virtual machines emulate this kind of keyboard. So we're going to go to the area in the Linux kernel that handles PS2 keyboards. So I'm going to open up Vim over here. And let's just go to the drivers folder. And over in drivers, I'm going to go to the input folder. Afterwards, I'm going to go to the keyboard folder. And I'm going to open the atkbd file. So we're going to open atkbd.c. As you can see, this is the AT and PS2 keyboard driver. So we're going to make our modification in this file. And I'm going to start searching here for a function that handles keystrokes, and I'm going to modify the key code. So let's just start by searching, for example, for the word code. And as you can see, we arrived at this function that is called atkbd receive byte, and this receives a structure that is called PS2 dev and also data. Now data is what is actually interesting for us, and this is data from the keyboard. So as you can see, what it's doing is it's setting the variable code over here to be data. So all I got to do to modify and make the keyboard act weird is just add 1 over here. So I'm going to do data plus 1. And now every key pressed is going to be offset by 1. So it's going to make the typing really weird. I'm going to show you in a sec. So let's go ahead and save this. And I'm going to compile the kernel. Now if it's your first time compiling the kernel, then you have to start with running make and then many-config and configure the kernel over there. I just kept everything there as default. And afterwards you can just run make to build the kernel. I like passing in -j to split up the build to multiple jobs so it goes faster. Let's split it up, for example, to 8 jobs. And I already built the kernel, so this will be pretty fast. So I'm just going to go ahead and run this. Okay, so the build's finished, and as you can see over here in the files that it built, one of the files it went through is atkbd, and that makes sense because we made a change over there. And eventually we have a file here that is the actual build of the kernel. It's telling us that BZ image is ready. So what I'm going to do is just go ahead and copy this file aside, because I'm going to later run this file with QEMU. So I'm going to copy it to my working directory. And now to the second part, I'm going to make a little user mode program that all I want it to do is just read input from the user. And this is going to be the init process of the kernel. For this, I'm going to go to POC, let's call it read, for example. And I'm going to open a new file here, call it read.c. Now what I want to do is use the read system call. So I'm going to open the man page category 2 for system calls, and then read. And first of all, you see that we need to include unistd, so I'm going to do that. Afterwards, I'll start my main function. And as you can see, read lets us read from a file descriptor, and I'm going to do this to read input from the user. First parameter is going to be the file descriptor. That's going to be 0 for stdin. So that's going to be the input coming from the user. Now the reason I'm doing this program is so I'll have something to type in something from the keyboard when the kernel is finished loading up, so I can test out the wicked behavior. Next parameter is going to be the buffer, and the size of the buffer, let's say 256. Now let's make a little greeting here. So I'm going to write, welcome to the cursed kernel. Don't forget the new line over here. Also, let's include stdio for the printf. And finally, let's define the buffer. Okay, so we're done with our user mode. So I'm going to save this and exit everything. And I'm going to use GCC to build this. And I'm going to use the static flag, which will make a static build of this file. It's important that it's going to be static because remember, this is going to be the only thing that is going to be on our distro. I'm going to pass in the C file and then -o for output. Let's call it init. Okay, now the binary file is ready. And you can see that it's indeed static if you just run ldd and then init. It's going to tell you that it's not a dynamic executable. And now I'm going to prepare the init RAM disk. So for this, I'm going to use a special program that is called CPIO. If you don't have this, you can just get this with your package manager. But anyway, the way it works is I'm gonna echo the files that I want inside of the archive. CPIO is what I'm gonna use to make the init RAM disk. So I'm gonna echo init because that's what I want to be inside my CPIO. And then I'm gonna pass this into CPIO. -O, that means create a new archive. -H, and that's gonna be new C, that's the format that the kernel uses. And I'm gonna redirect this into init.cpio. Okay, and now the archive is ready, so we're gonna see it right over here. Now I'm just gonna go ahead and move this to my working directory. Okay, now everything is ready for demonstration. So we're gonna see the files over here. Here's the BZ image, and here's the init RAM disk. So to run QEMU, I'm just gonna run QEMU system x86-64. I'm gonna pass -kernel, and here I'm gonna pass the BZ image. And I'm gonna pass -init-rd, and the init CPIO is gonna go right over here. Okay, and you can see our message right over here, welcome to the cursed kernel. Now I'm gonna go ahead and open the on-screen keyboard. And if I go ahead and, for example, type Q, you can see it's actually typing W. If I type in G, it's actually typing H. That is because H is right next to G, and W is right next to Q. So if I type in 5, for example, it's going to type in 6. Subscribe for more programming videos, and thanks for watching.